we had this opportunity to go out and talk to customers, end users, different stakeholders in the environmental and wastewater industry, who kind of brought up this consistent need for better PFAS treatment technologies, and specifically this gap in PFAS destruction solutions. So we took that signal from the industry and spent that year of 2020 largely in our bedrooms writing proposals, mostly through the SBIR program. And we were really fortunate to have, within a few months of each other, phase 1 awards come through from the NSF, the US Air Force, and the EPA to develop different aspects of our technology. And that was kind of the kick in the pants we needed to commit to Aquagga full time, hire our first couple employees, find an office space, find some lab space to do prototyping, and turn that what for a lot of companies and a lot of individuals was a fairly stagnant year into a very productive year of bringing in some early traction and early funding to take this idea from the lab and start to prototype and develop an MVP to get out in the field.
Welcome to The Meter, the podcast that digs into the origin stories of the founders, inventors, and entrepreneurs creating exciting innovations in a less exciting but very necessary field, the utilities. We go deep into the trials, risks, and successes that these folks experience, all to make our basic necessities run better, whether that's your tap water, electrifying your home, or bringing internet to your phone. I'm your host, Andrew Dugan. In kitchens across the country, you'll find nonstick pans and the people who swear by them. No more scraping eggs off of the pan once you're done cooking. Everything comes off in one piece. It's a modern miracle. But as forever chemicals, or PFAS, have entered the zeitgeist, more people are questioning the side effects of the chemicals that make these products so miraculous. See, PFAS chemicals are able to achieve that non-stickiness because they're incredibly stable. They don't interact with your eggs on a molecular level, which is why your breakfast comes straight off the pan. But that same stability is what makes it so difficult to break those chemicals down once they've entered the environment, our food, bloodstreams. The issue is so pervasive that the federal government has been throwing gobs of money at really bright people who have figured out how to break these polyfluorinated chemicals. So technically, forever chemical is a misnomer. But it takes a lot of work. Heat, pressure, pH, all have to be brought to extreme levels to break down PFAS, which also means it's incredibly expensive. Chris Woodruff, along with his co-founders at Aquagga, are one of these groups that have been leading the way on PFAS destruction technology. They've won grants from various government agencies and now run a mature business, and they did it all in 6 years. But it all started at the University of Washington as grad students with a peculiar name in mind.
It comes from the extinct type of zebra, the quagga, and the intent behind the name is kind of in line with the intent behind the company and the mission. There's a lot of unicorns in the startup world that are meant to be big and disruptive and grow fast and break things. And the ethos behind the quagga or the zebra is to balance the black and the white. So, build a sustainable growing company, but also tackle, a mission-driven problem. So with, PFAS, there's obviously huge environmental and public health concerns. So that's where the name came from. We incorporated as a public benefit corporation, which allows us to make decisions that are driven by stakeholders beyond just company shareholders. So, allows us to operate with long-term impact in mind as well as growth.
It's awesome. And when you went to the University of Washington for graduate school, at least from what I can tell, that's where Aquagga was born. How did you bump into Brian Pinkard, your current CTO? How did the University of Washington inspire you guys to go forward with Aquagga?
Yeah, it's a great question. So I would say just timing and good fortune. I have always been curious about entrepreneurial endeavors, and I went back to grad school at the UW after spending almost 10 years in industry and wanted to kind of pivot my career a bit. And happened to go to some startup programming at the university, and Brian was pitching about PFAS and AFFF and, these chemicals that are in all our water, and we need to do something about it. And it kind of grabbed my attention right as I happened to be finishing my master's degree. That kind of just original engagement, started doing a bit of part-time work and some consulting, and then came on as a late co-founder to the company alongside Brian and Nigel.
Soon after you graduate, a couple months later, you join Aquagga, and pretty soon after you guys do that, COVID happens, March 2020, and it makes your start a little rocky. I think you mentioned it was tough to get in the laboratory. What's happening in that first year in the midst of COVID?
Yeah. So, essentially, like we went through the NSF I-Corps program just before COVID started. So we had this opportunity to go out and talk to customers, end users, different stakeholders in the environmental and wastewater industry who kind of brought up this consistent need for better PFAS treatment technologies, and specifically this gap in PFAS destruction solutions. So we took that signal from the industry and spent that, year of 2020 largely in our bedrooms writing proposals, mostly through the SBIR program. And we were really fortunate to have, within a few months of each other, phase 1 awards come through from the NSF, the US Air Force, and the EPA to develop different aspects of our technology. And that was kind of the kick in the pants we needed to, commit to Aquagga full time, hire our first couple employees, find an office space, find some lab space to do prototyping, and, turn that, what for a lot of companies and a lot of individuals was a fairly stagnant year into a very productive year of bringing in some early traction and early funding to take this idea from the lab and start to prototype and develop an MVP to get out in the field.
And so within the first year, correct me if I'm wrong, you get a pilot, a bench scale pilot, and they paid you for it. Is that right? Who was that first client of yours that you guys got within the first year?
Yeah, so that was, I think, in June or July of 2020, and it was actually a local company that works in the wastewater treatment space that we connected with through a business accelerator, through the Cascadia Clean Tech Accelerator. You mentioned, or you asked a bit about accelerators. We've been fortunate to be involved with a number of programs, and network and mentoring and community is one of the strongest things you can gain from an accelerator. And we got this introduction to a company that was looking at managing landfill leachate and kind of starting to explore treatment of PFAS and leachate. So our first paid bench test was, I think it was $3,000 or $3,500 to do a couple days of bench work looking at some real world leachate samples from one of their sites. It was early traction like that is really important for companies both to pursue non-dilutive funding sources like SBIR funding. The government wants to see that there's a commercial customer and user at the end of the day before funding technology development. And then also any investors want to see similar traction, and that can be customer revenue or SBIR dollars or other non-dilutive funding. So it's all signals of early traction for an early startup.
Absolutely. And that's honestly incredible. Even if it was $3,000 within the first few months of your company to already have a paying customer in water and wastewater is really, really fast. And so that's really exciting. So you have this funding come in and you already get a customer pretty soon after. What are the results of the bench scale?
We saw very high destruction performance, like 4 log reduction, I think, if I recall off the top of my head. And I remember having a debrief conversation with the customer saying, okay, yeah, this is great. You've proven you can destroy PFAS, but can this scale? You've done this in a 50 milliliter batch reactor system in a university lab. We were still working in the labs at UW at the time. What do you do with this? Treat hundreds of gallons per day or thousands of gallons per day. How do we translate this lab-based technology into a relevant continuous flow system that actually meets our needs? And I think that's a common question that early stage startups get, and that's essentially what we spent the next 2 or 3 years demonstrating, that we could take a lab-based system and build a standalone portable unit to bring out to customer sites to show that, yes, this is robust, this is reliable, this can be developed in a modular system that's easy to ship, easy to integrate, easy to operate.
And you mentioned in the pre-show questions that was a lot harder than maybe you anticipated. You had these great results from the bench scale, and they go, well, okay, can it be continuous flow? Like, can you do more flow? And from what you told me, going from that bench scale to that commercial scale product was maybe took more iterations than you thought, which I think is really common for the folks that I interview. They all go through this process that you mentioned, but tell me about what that was like for Aquaga. What were the speed bumps that you hit that maybe slowed you down or made it take longer than you thought it would?
Yeah, I think, a common challenge for early stage hardware companies is finding reliable manufacturing partners that
Mm.
are able to work at the scale that makes sense to build one or two prototypes of a system. So, that wasn't really a challenge for us, was not necessarily can we work with a partner to design, build, and manufacture these systems, but can we get somebody's time to, do some early prototypes for us at a cost that we can afford. And alongside that, we also had some supply chain challenges in 2021, early 2022. If you recall, there was huge shortages of microelectronics. So getting industrial control systems, as a startup, you're kind of last in line for vendors to prioritize with limited supply. So, it took us 6 or 8 months to get, our first controllers in stock. And I think we actually pivoted and built our first standalone system off essentially like a research scale controller, instead of, getting something that was more in line with industrial expectations, because that was what was available, and that it was what allowed us to get our first system operational.
Was that experience part of what inspired you to do the ORISE Arctic Innovator Fellowship up in Alaska?
I was very fortunate to be selected for this fellowship through the Department of Energy ORISE program, that is really a technology commercialization fellowship. So it's intended to help support early stage innovators, early stage companies to develop technologies that in this case had a relevance to the Arctic and to the state of Alaska.
Mm.
Alaska is sort of disproportionately affected, if you think about it on like a per population basis, by the PFAS problem, because of the remote communities and the high number of military installations and airports in the state that have had historical use of firefighting foam. So Fairbanks itself has sort of three hotspots for PFAS pollution, from the airport to a fire training center to an Air Force base just down the road. So this is kind of an issue that's near and dear to the city of Fairbanks, and really impacts folks on rural water supplies. So that was what brought me up to Alaska. I was essentially doing Aquagga work, but supported with this fellowship from the DOE.
Through that, you actually end up working with the Fairbanks Airport to deal with their A3F. Is that right? You are ultimately able to take them on as a client, or at least a pilot, and help them destroy PFAS at the airport.
Yeah, this was a really unique program. It was jointly funded by the FAA and by the Alaska Department of Transportation. So it was our first field pilot for, bringing a HALT system out to a customer site, and we were addressing a former fire training pond that had been impacted by decades of AFFF use. So we got the chance to work with a number of project partners, including another PFAS treatment technology, foam fractionation, to show that we could bring these two systems on site and basically pump and treat water out of this pond, separate and concentrate the PFAS with foam fractionation, and then destroy those residuals with HALT. So, it was a project that came to be out of some early relationships through UAF and through an accelerator we took part in up in Alaska, that turned into, our first pilot opportunity, and a really great case study for us to show that this technology could be taken out of the lab, paired with other water treatment technologies, to provide, an end-to-end, cradle-to-grave PFAS treatment solution.
Absolutely. And so you guys now have three different sizes of your HALT system. I'm curious, kind of like going from bench scale to that first size, I assume the Colt. Did you encounter other engineering issues going from colt to steed to stampede?
Yeah, and it's kind of interesting. So we developed the steed system originally with funding from the EPA and also from DARPA, and then the Colt was sort of a scaled down version of the steed. So we developed the steed based on existing kind of lab based systems we had running previously, and then for some kind of niche applications that require lower flow rates, then to develop so we've learned different things about scaling up and scaling down HALT systems based on product needs, which are, at the end of the day, driven by customer and industry needs.
Mm-hmm.
Some of the key learnings are, what features are valuable in some industries, but maybe redundant, or, introduce cost in other industries that are not really needed or desired by the customer. And then going from different scale systems, like what sort of redundancy to design into systems, what's a reasonable amount of operation and maintenance for different customers. So those have been some of our core learnings from going out and completing these pilots the last couple of years that we're taking into our continued product iteration and design of different scale systems.
Aquagga has been a part of at least 7 accelerator incubator programs, and you've been around for about 6 or 7 years. Clearly you're very good at getting into these programs, and the problem you're solving is very pertinent. But, I'm curious, when you guys started this company back in 2019, going into 2020, were the accelerators and the incubators always a part of your strategy to succeed as a company? And I'm also curious, what would have been the benefits from being a part of these programs for Aquaga?
Yeah, I think, it's a very good question. And I wouldn't say that accelerator participation was directly part of the strategy, but more generally, the programs we've participated in have kind of aligned with our different needs as the business has evolved. So, early accelerators really focus on developing your business model, understanding what your key value propositions are, and getting in the rhythm of communicating that externally to different stakeholders. So, there's some more like fundamental startup 101 learnings from some of the programs we went through, right when we were starting up, spinning out of the university. And then kind of as we've transitioned, our needs have changed, and they can be more focused on investor introductions and refining a investor targeted pitch, or focusing on go to market strategy for different verticals. So I think that's probably the advice I give other startups is don't hop between accelerators just to show traction or to show that you can get accepted into these programs, but go into them with a clear focus and objective, and make sure that the accelerator, has a track record of providing that value to participants as well. So it's kind of a bit of reverse diligence that startups should do on programs before kind of diving into them, recognizing that there can be pretty significant time commitments associated with accelerator participation.
I would imagine so. And that's really good advice. And not just being an accelerator just to be an accelerator, but that mutual need, it needs to be there.
And I think it's easy to, there's a lot of, I'll just generally say, homework that comes with different accelerator participants, and like it's important to frame it or shape it to match with your company needs. Like, don't do things that you
Mhm.
shouldn't already be doing as a company. And that's kind of an indicator that you've chosen a good program. If the deliverables associated with the accelerator, the questions that you're being asked are things that are coming up in your day to day business operations, that it's a good sign that they're, the feedback you'll get in the mentorship are aligned with, what you should be focused on as a company.
Fast forward to 2023, Coma Public Utilities in Aquaga's backyard, one of your pilots, it reported that the HALT system was destroying PFAS in their water. How did that feel, having, again, a local city be helped by HALT?
Yeah, so this was a project we just wrapped up in I think it was originally funded in 2023. We just did the field work in Q1 of 2025, and it was really validating to get to do a project in our own backyard. Prior to that, we had
Mhm.
shipped HALT systems up to Alaska, to Illinois, to California. We'd done these projects all over the country, but we had not seen a lot of opportunity or traction here in Washington State. And when we first moved the company to Tacoma, we were based in a office space that was shared with some researchers from the University of Washington, Tacoma, and the city of Tacoma. And that's how this original grant proposal came to be, was just through the network, like literally down the hall from us. So, a year and a half, 2 years down the line to actually take that, some lab work and the data that we put into that proposal and take it out into the field and show that, again, working with other treatment technologies to separate, capture, and destroy PFAS on site at the wastewater treatment plant was hugely meaningful to us as a company.
And it does seem that now you are getting a lot more recognition in Seattle as a local clean tech company. And, coming in 2025, you guys had a huge year, right? Frankly. You won WEF's Innovative Technology Award. You guys are hiring people, you're landing contracts with government and industry. You're continuing to refine the HALT, which I'd love to learn more of how you guys are continuing to better your products. You're partnering with universities like the Colorado School of Mines. You even won the Pacific Northwest Climate Week pitch contest recently.
Yeah, I would say 2025 was sort of a continuation of 2024, and that I think we completed 9 customer pilots in 2 years, which for a company that grew from like 15 to 23 employees in that time, it's a lot of project coordination, it's a lot of field work, it's a lot of logistics. So we certainly have been busy the last couple of years, and really the goal of all that is to continue, not necessarily but the development, but the evaluation, optimization, and proving out of HALT for different customer needs. So I think a lot of these pilots, it's not necessarily about just the stats of doing X number of pilots in a year, but saying, okay, what do we learn from this? What is the follow-on interest from this customer, and what can we take from the pilot to inform our continued product development, our customer development, our business model, things like that, to kind of get beyond that pilot phase as a company and look towards more broader scale adoption. There's no shortage of cliches around death by pilot in the water wastewater industry. So, we have to be
absolutely
hyper aware of that precedent and do everything we can to kind of fill that gap beyond pilots with follow-on opportunities.
You have held the role of COO of Aquagga for about 4 years now, but the company has grown a lot. You guys have had a lot happen. I'm curious, from your perspective, how has your role as COO evolved as the company's evolved? Whether, that's day-to-day things, or how you've delegated, or what it is you do.
Yeah, it's a really good question. And I think, for a lot of early stage startups, first hires are generally kind of jack of all trades, master of none type experience and skill sets. And I think that's, how I kind of shifted into the COO role after a year or so at Aquagga. Just, I've got a kind of a breadth of experience and can plug, fill different needs or gaps in the team at any one point. And that's how we approach generally hiring our first few employees, recognizing that there's, in a company of 5 or 6 employees, there's a lot of different activities that happen on a daily, weekly basis that, you can't have people coming in and saying, oh, that's not my job. I don't want to travel, or I can't do this, or I can't do that. And, as we've grown, we've been able to build more structure into the organization, bring in some more specialty skill sets for key roles, while maintaining some of that core kind of ethos and mindset around wearing multiple hats and just general cross-functional collaboration. So, my specific roles and responsibilities have evolved a lot in the last 4 years. And, as we've grown to a team of 23, there's things I get to delegate that I couldn't 4 years ago. And I think generally speaking, try to focus on the activities that are highest value to the company, and, help us move towards next milestones.
You guys have made it this far without taking any dilutive funding, which I think is really impressive that you've made it this far. You guys have been very good about the grants and finding paying customers very early on. And now going into 2026, you are getting geared up for a Series A. How does it feel to be making that step of taking funding?
Yeah, yeah, it's a good question, and I'll correct you slightly in that we have yet
Okay,
to close a priced equity financing round. So we have
gotcha.
taken some dilutive investment in the form of safe notes and convertibles. So we do have the support of a number of angel investors, but we haven't taken a venture round or a priced financing round. But if you look at our overall how we funded the company to date, it's about $2 million of dilutive investment versus roughly 12 to $14 million of grants, contracts, and customer revenue. So we have, seen most of the traction we have seen and done most of the development largely with federal non-dilutive funding through programs like the SBIR program and similar contracting mechanisms. So, and I think it's really key especially for clean tech and hardware startups to get that early traction. It's really hard, especially, in the current market, to bring in early stage investment for lab-based research or prototyping or early MVP development. The most successful startups are able to do that with some traction of non-dilutive funding. So we happened to start the company right around the time where there was this sort of deluge of funding from different government sources to start to
Hmm.
tackle the PFAS problem. So I think, timing is everything with startups. We were really fortunate to kind of go out and do that customer discovery and, shift our focus to PFAS at a time when there was, sort of a federal mandate to help develop technologies to tackle this problem. So, it'll be harder for other companies to follow a similar track, certainly in the current landscape. And hopefully that shifts in the future. But looking ahead, we recognize the need to scale up our system, scale up team if we want to really kind of meet the goals and the vision we have for the company and for the technology and the ability to really tackle the PFAS problem at scale. It's not something we're going to do by ourselves. So finding the right
Hmm.
partners, whether investors, customers, project partners, is how we envision when this company growing this technology to make the biggest impact.
And it sounds like you found them, because I think in Q2 of this year, you're converting at least one of your pilot projects into a long-term commercial installation, which is a big deal. Are you guys looking at any new industries as well as you look to grow?
Yeah, it's a great question. So yeah, we're excited to have our first long-term installation at a chemical plant in Q2 of this year. And, a lot of our traction to date has been from government sites, government customers managing LF impacted sites. But, we are trying to broaden our reach and look at other verticals that may be moving in parallel to the government as a customer. And, we're seeing a lot of interest in the industrial space. And there's pharmaceutical applications where PFAS and specifically TFA is very heavily used. And we know that is a very good use case for HALT. It's a very low OpEx application for us where we're very confident in high levels of destruction and at a very low cost. So, we're optimistic about that market vertical and generally that need for TFA treatment across different industries, especially as regulations are starting to move in Europe and, other parts of the world around PFAS beyond PFOS and PFOA, which are historically the ones that have been most well researched and had the first regulations here in the US and elsewhere.
When I was thinking of you guys growing, I hadn't even thought of geographically. You mentioned Europe, and Europe is perhaps one of the more aggressive regulatory environments for PFAS, but are there any other places that you're looking, whether it's Australia, Asia, Africa, South America? What strategic geographies are you guys looking at to grow your market?
Yeah. So the first couple you mentioned are certainly ones of interest to us. Australia has, a pretty significant historical use of AFFF for military applications. So there's a pretty well documented challenge around site remediation in Australia. And we're also seeing an uptick in interests from Asia and specifically from Japan, largely around the microelectronics manufacturing and also some landfill leachate applications. So we were excited to have our first paid bench test from a Japanese customer at the end of 2025. Our sales director is heading over to Tokyo next month for some follow-on meetings around that project and some other opportunities. I think, generally speaking, the areas we're seeing the most interest are in Europe, Northern, Central Europe, and from Japan.
Very exciting. You guys came out with the Stampede, I think, last year, which is your largest model. Not to rush you, but are you going bigger? Are you guys looking at getting to that next echelon of scale? Yeah, I'm curious what your R&D folks are up to.
Yeah, so the Stampede system, we're targeting roughly 1 GPM, so let's say 60 to 100 gallons per hour. Our focus has always been on developing like compact modular systems that can easily be integrated at sites versus building these, large infrastructure projects.
Absolutely.
Like standalone PFAS treatment facilities. It's a bigger undertaking than getting a customer to add another bolt-on technology to the end of their existing treatment plant. So I don't envision we will build a individual system larger than the Stampede, but thinking how we can put multiple systems in parallel alongside upstream concentration technologies. So that's how we have always envisioned scaling up HALT and scaling up PFAS treatment solutions more broadly. It's all about providing the right assembly of different technologies to meet whatever the customer site needs.
Absolutely.
And you asked a little bit about what our R&D team is up to. There's always continued optimization of the HALT process, the fundamental chemistry behind the technology. We're always looking at ways we can make our systems more cost effective, especially operational costs, looking at maximizing system lifetimes and improved O&M schedules. So that's, kind of one core element of our R&D team's effort, alongside doing a lot of customer bench testing and, exploring new waste streams, new site-specific needs that customers are coming to us with, looking at, the chemistry of HALT on their needs, as well as what other treatment technologies might pair well to provide, as I said, that kind of end-to-end solution.
That was Chris Woodruff, the COO at Aquagga. Despite the current political landscape, which has seen PFAS regulations be stripped away or diluted, there do appear to be states and industries motivated to break the PFAS pollution cycle anyway. And there's also a number of competitors trying to figure out how to break these chemicals down as cost effectively as possible, each with their own approach. So it'll be really interesting to watch Aquagga in 2026, 2027 as their momentum grows and as things shift. Well, that's it for this episode. Thank you for listening to the end. I'm Andrew Dugan, and this is The Meter.